Hi everybody, welcome to another video on college algebra, section 2.6, combination of functions and composite functions. First, domain of a function. If f of x is a function, then the domain is the largest set of real numbers, for which the values of f of x also real numbers, meaning that the set of all the x values that make the function defined. Because of that, when we divide by 0, it is undefined. So when we divide by 0, let's say the numerator on the top, it is going to be undefined. So if we have something divided by something, the denominator cannot be equal to 0. So the bottom not equal to 0 for the function to be defined. Also, when we have an even root, and if we have a negative inside an even root, this is an even root, square root, fourth root, so on, it will be imaginary. Since the domain we only consider the real values for the function f of x, will require anything inside an even root to be greater than or equal to 0. So those are the two rules we need to watch out for. Now let's look at this example. Find the domain of the following function: f of x equals x squared minus 7x. It doesn't fall into one of these rules. So this one is defined everywhere because we don't divide by anything and we have no even root. So this function is defined everywhere. So we say domain is all real numbers. And we can use this symbol for real numbers, the set of real numbers. Or if we're going to draw a line, we're going to select the whole line. Or if we use the interval notation, it will be from negative infinity to infinity. Either one of these is the domain for that function, which is everything, all real numbers. Right. Next, we have a square root or an even root here. We cannot have negative inside the square root, so the domain is whatever make it positive or 0. So we said x minus 1 must be greater than or equal to 0, and minus 1 on both sides of x greater than or equal to 1. Right. So we write the domain x greater than or equal to 1. If we draw a number line, it will be greater than or equal to 1, so on the right side of 1, greater than on the right side. It has the equal sign, so it will be a bracket. So the domain will be from 1 to infinity. So when we have the square root, we have to watch out for that. Inside the square root must be greater than or equal to 0. Right. Next, we have a rational function, or we have something divided by something. In that case, the denominator must be not equal to 0. So pretty much those are the two rules we need to watch out for. So here we have 2x plus 5 cannot be equal to 0. And subtract 5 on both sides, we have 2x not equal to negative 5. And divide by 2 on both sides. So if x not equal to negative 5 over 2. Right. So the domain is x not equal to negative 5 half. If we draw a number line and we have negative 5 half, we can have the right side, we can have the left side, but we cannot have the middle. So in interval notation we will say negative infinity to negative 5 half, but not including 5 half. So we have the parentheses, and then we write union, mean all here, or from negative 5 half to infinity. Right. So that those are the two things we need to watch out for when we try to find domain of function. If it's not in that form, we don't need to worry about it. Right. What next? This one we have both. It's in under the square root and under the denominator. So we need to watch out for those two things. First, it need to be not equal to 0. Because we divide by that. Denominator cannot be equal to 0. And then next, we're going to need both. Inside the square root have to be greater than or equal to 0. Right. Now we square both sides. When we square both sides, remember we should check the answer. So have 2x minus 3 equal to 0 plus 3. So 2x equal to 3 and divide by 2, we have x equal to 3 half. And the thing is, this is not equal to, so we make it not equal to. Right, so x not equal to 3 half. Right here, I will just solve for x, so it's simple. Plus 3 on both sides. 2x greater than or equal to 3 and divide by 2. Right, so we have x not equal to 3 half and x greater than or equal to. The problem is it is and, meaning the intersection, so both of them have to happen. So we cannot have the equal sign here, because if we have the equal sign here, that one doesn't work. So we can have greater than but not equal to, because if it's greater equal to, this works, but that is not. We still divide by 0. So bottom line is, when we put these two together, the domain is only greater than 3 half. It cannot be equal to. When it equal to, it will be equal to 0, and divide by 0 is undefined or imaginary. But we only worry about real numbers. So, I'm sorry, divide by 0 is undefined, period. Right. So the domain is x greater than 3 halves. Greater than on the right side. And it doesn't have equal to, so parentheses. Right. Next we have this function, x squared plus 4 at the denominator. Therefore, it cannot be equal to 0. Right. And then we just solve for x. Subtract 4 on both sides. X squared not equal to negative 4. And to get back to x, we'll take the square root on both sides. Remember, when we do that, we're going to put plus or minus. So with that, we have x not equal to plus or minus square root of negative 4. Now, the negative inside the square root, so that is imaginary. So x not equal to plus or minus that negative inside square root is I, and then square root of 4, which is plus or minus 2i. Right, now, so as long as x not equal to plus or minus 2i, we are good. However, remember, the definition of domain is the set of all real numbers. So the values of x must be real numbers, and of course real numbers is not equal to imaginary. So in that case, we say the domain is going to be all real numbers, because all real numbers different than these values. All real number, we can use the set of all real numbers, or we choose the whole line, or we use interval notation. So that is the domain of a function. Next, algebra function. So when we have two functions, we can add, subtract, multiply, or divide. And so we just add, subtract, multiply, or divide. The only thing we need to watch out for when we divide is that the denominator cannot be equal to 0. Right? So it's very straightforward. So first, we add two functions f and g, meaning we add the function f of x plus the function g of x. So f of x is 2x minus 1 plus x squared plus 1. Remove the parentheses, 2x minus 1 plus x squared plus 1 minus 1 plus 1 cancel out. We have x squared plus 2x. Right, very straightforward. And next, we have f of x minus g of x, but we write like this. So we can say we have the function at 3, function f at 3 minus the function g at 3. So we're going to put 3 in for x. Whatever we have, subtract when we put 3 in for x here of the g function. Right. So that is 6 minus 1 is 5. And then that is 10. So we have minus 5. Right. Next, this means multiply together. By the way, when we multiply, we do not put anything in between the two functions. So we're just going to write like that. The function is 2x minus 1 and x squared plus 1. And then we just multiply them out. 2x cubed plus 2x minus x squared minus 1. Right. Of course, we can also write in the decreasing order of the power of x. 2x cubed minus x squared 2x minus 1. Right? Simple enough. Next, this means we divide them. So f of x divided by g of x. F of x is 2x minus 1. G of x, x squared plus 1. And this is similar to the last problem we did earlier. The domain of this is all real numbers, because if we solve for this, x is not equal to plus or minus I, and but when we divide them, we just divide them pretty much. Next, we have composite function. Composition of function f and g is denoted by f, a little circle g. That means f of g of x is defined as follows. So the domain of the function is the set of all the x such that x is in the domain of g and g of x is in the domain of f. Right. So the combination of two functions. Combination of two functions is that. Right. Now, just one thing. We said x in the domain of g and g of x in the domain of f, meaning the inner function have to be defined and the outer function have to be defined. We do have some example. One example of that. Right. Now let's just find f of g of x and then g of f of 1. Right. Now, if x squared minus 2x is f of x and g of x is 2x plus 1, then find f of g of x. This means f of g of x. Right? Now, ignore what inside the function f. It's going to be that square minus 2 times that. Whatever we put in the parentheses for the f, we're going to put in every parentheses here. So we have one place for x, that's just a parentheses, x, another parentheses, and x, a parentheses. So it doesn't matter what inside it. If we put that in here, we have to put that everywhere. So if we put g of x inside, we have to do that everywhere. Right. So that gives us g of x is 3x plus 1 and g of x 3x plus 1. Right. Of course, we can multiply them out and simplify it, but that's not the point. The point of this problem is to find a combination of f and g. Right. Next we want g of f at x equal to 1. So the first is the outer function. Inner function is f of 1. Right. Now, doesn't matter what inside g of x is 3x plus 1. So this equal to 3 times something plus 1. So whatever we put in this parentheses, we have to put in that parentheses. So if we put f of 1 into this parentheses, we have to do the same for the other. Now we just need to find f of 1. So f of 1, I'm just going to put 1 in for all the x here. One minus 2, so it's negative 1. So we have negative 1 for f of 1, so we have 3 times negative 1 plus 1, negative 2. Right, so very straightforward. Right, let's go for something a bit more complicated, and this time we're trying to find the domain of the computation. So this is g of f of x. So we write first g of f of x like that. Now, doesn't matter what inside the function g. Function g is 3 divided by something. So replace both x's by parentheses. Now, what inside that parentheses will be inside this parentheses as well. Right. So that gives us 3 over 2 x minus 1. Right? Now, what we do here is we can write 3 divided by 1, and we divide fraction, so multiply reciprocal. We're just going to flip it. So we have 3 x minus 1 divided by 2. Right? So that is the computation. Now, how do we find the domain? Remember, the domain of the computation is the domain of the inner function and the domain of the whole thing. So we say domain of the computation is domain is equal to domain of the inner function. It would be intersect, meaning both of them have to occur. Domain of the whole thing. Domain of f of x. Domain of f of x is x not equal to 1. And then domain of g of f of x, we do not divide by any x. We have no x at the bottom, so which is good. So domain of that is all real numbers. So put them together, we just have x not equal to 1. On the right is okay, on the left is okay. Right. Notice that that upside down u is intersection, so we have to have both of them. The u is the union, so either one of them. Right. So that is domain of g of f of x. Now, I do want to calculate the domain. Do want to calculate the domain of f of g of x. Let's do that as well. So for f of g of x, so we start with the function f is 2 divided by something minus 1. Right? Instead of x, I use the parentheses, something minus 1. Now if we put g of x in that parentheses, so that's what we do here. Right, just gonna do that. So we have 2 3 over x minus 1. So one way we do that is just multiply the reciprocal. Here we can also do that, but we have to combine this into one big fraction and then we multiply the reciprocal. Or we can also do this. If we multiply top and bottom by the least common denominator of x, so multiply, because all of this, the 2, the 1, and 3 over x, only the x is at the denominator, so I multiply top and bottom by x. With that we have 2x, and x times 3x cancel out, we just have 3, and 1 minus x, minus x. Right, so that is the combination of f and g. Now, if we try to find the domain of this, remember, the domain of the combination is the domain of the inner function and the domain of the whole thing. Domain of the inner function and domain of the whole thing. So domain of the inner function is g of x. It's the inner function. And I'm using the intersection for n. Domain of the whole thing. Which is f of g. Right. Domain of g of x. G of x is 3 over x. Which is x not equal to 0. And the domain of f of g, with domain of this denominator not equal to 0. So we have 3 minus x not equal to 0. So x not equal to 3. Right? 3 minus x not equal to 0. Plus x on both sides, so we have this. Bottom line is we have x not equal to 0 and x not equal to 3, so we can have everything else but those values. So we say negative infinity to 0, union 0 to 3, union 3 to infinity. So union, once again, we can have in here the union is all, so here, all there, all there. But in the domain have to be the intersection of domain of the inner function and domain of the whole thing. Both of them have to occur. So this is n. Right, just like that. Right. Next is the opposite direction of combination is decomposing function. So now we can write a function as a combination of the other two. So do that, very simple. If I just put the parentheses around something, in that case, I say I have the function of the parentheses where the parentheses is equal to x squared plus 1. So we decompose that into two functions, a square root and that. And now properly we just going to say this is the square root, so we say the square root of something, and that is the outer function, and the inner function is the second function. And so just like that. It's just the way we define it. By the way, we can also write like this. Just going to put the parentheses around something. If this is the case, we have the function of square root of the parentheses plus 1, where the parentheses is x squared. So in that case, we can also say f of x is equal to square root of, replace x plus 1 for the outer function, the first, and the inner function, the second function. Either way, we should have that. So we just put the parentheses around something, and the function will become 1 over a parentheses with the parentheses equal to 2x minus 5. And then we have the first function is the outer function, and the second function is the inner function. Right. So with that, we finish section 2.6. Thank you for watching. See you in another video in course algebra.